So this is our molding room. And the molding room is where we actually mold the materials, the plastics, over these devices. We start with just a library of different types of plastics and foams. And these plastics all have slightly different properties. Some are stiffer, some are more flexible. And then we add these colors up here for shape. We also use a lot of foams for padding purposes usually. So we start with a mold that just came out of the other room. And it's all been modified. You can see the different colors. This has also been marked up so you can see where we're going to be putting pads and joints and trim lines and things like that are all laid on here. And you can see the different colors. So again, the colored areas where we added plaster, and typically the whiter areas are where the plaster has been removed to increase pressure. So then what we do is we take these big sheets of plastic and we put them in these infrared ovens. And once the plastic is set in here and gets to a certain temperature, when it's ready to be molded, the plastic is brought out, it's draped over a mold, and then we apply vacuum to suck the plastic basically down to the mold. And here we've got a nice American flag graphic on here. So now we've actually made the device. This plastic that we used here is what the device is going to be made out of. So from here it just needs to be trimmed and finished. We'll talk about that in the next lab. There's another process we do in here too, and that's called laminating. I'm going to talk about this real quick too. So this is a mold for someone who's lost their arm above the elbow, and we're making a diagnostic socket or a test fitting. So this is the type of a plexiglass that again is molded in that similar fashion. The beauty of this is it's not as strong as it would be for a real device, but it's see-through. And because it's transparent, we can see exactly how the limb fits inside, and we can make also changes by heating and flaring and that kind of stuff. Once the shape is exactly the way we need it, so it fits not too tight, not too loose, applying pressure in certain areas to control, in this case, the humerus as it goes into flexion and extension. And we know all that is working well, then we can go ahead and start to finish the device. Over here we have a large fume hood. This fume hood is designed actually to take out both lighter than air vapors and lower than air vapors, because we're using some very toxic chemicals in here, a lot of toluenes and benzenes from adhesives, but also a resin. And this is very similar to how you make a fiberglass boat, if anyone knows how that works. But you start with a resin, and this is an epoxy modified acrylic resin. And what you do is you have a mold that we made in the other room, and you cover that with layers and layers of material. And I can show you some of those. Here, for example, this here is a mixture of nylon and fiberglass. And that's got certain strength and stretchy properties to it. And then we also use materials like this, which is like a carbon-based material, a braid, for a super strength in certain areas. And then we can also use little bits like this when you need specific strength in certain directions. And the braid of these carbon fibers go in a certain direction for strength. So once we lay up all these materials, and there could be 20 layers of material in whatever orientation we need to make the device both as strong as it needs to be, but as lightweight as it can be too. Then those molds are brought over here to these other stations, and I'm sorry there's nothing in here right now, but there's a plastic stretchy bag that gets stretched over the whole thing, sealed down here, airtight, and then we have these special funnels that we pour the resin into. And once that resin gets poured in, we apply vacuum, and the vacuum basically encourages the resin to saturate that material. We want it as thin as it can be under pressure, and then once that is all spread equally and the materials absorbed it all, then we time the material with chemicals to go off in a certain amount of time, and you get this super hard lamination, multiple layers of material to get this hard substrate. And we'll show that in the next room. So let's go over there.